So for question 1.4, okay, we need to simplify short oriented expression. So here, few prerequisite. Number one, you need to remember your quotient rule, product rule. Number two, you know how to use chain rule in a derivative, find the derivatives of a triple function. Okay. Then okay, first one, to differentiate x square sine phi, what we need to do is just basically use the product rule. We recognize that this is a u and this is v, and the derivative of a product basically is a differentiate u. So remember the product rule, right? Dy dx is basically differentiating u times v plus differentiating v times u. Okay, then from here, differentiating that, so differentiating x square sine 5x, right? This will just give us the derivative of x square, which is 2x multiplied by v plus dv dx, which is 2x multiplied by u. Okay, so sorry, dv dx, wrong. Silly me. Okay, so it's basically x squared multiplied by the derivative of sine phi x. So sine phi x, you will differentiate this, you must remember that you need to engage the chain rule, which will give you 5 cosine 5x. Okay, so this is u, this is v, this is du dx, this is v, this is u, this is dv dx. Okay, then with that, simplify the answers. And the answer comes out to be as follows. Okay, so this is for part A. Okay, for part B, I need to differentiate basically 1 over cosine x lah. Then if you think about, actually this one is if you want to simplify, you can also remember that the derivative is actually basically nothing but the derivative of secant x. So because 1 over cosine is secant, then the derivative of secant is secant tangent, right? So if you want to show this again, you can put it in the index form. Let's say if I do not know that the derivative of secant is secant tangent, I can write this in the index form. I see the outside function here as a so-called something to the power negative 1. I see the inside function as the cosine x. Okay, if I differentiate the outside function, negative cosine x to the power negative 2 multiplied by the derivative of the inside function, which is negative sine x. With that, we have sine x over cos square x. And if you want to simplify this, I can write this as basically sine x over cosine x times 1 over cosine x. This is basically equals to tangent multiplied at secant x, and we are done. Okay, so this is for part B. For part C, requires us to differentiate x cubed plus 1. Okay, so from here, what we need to do is we just treat it like a product rule. Okay, so we are supposed to differentiate okay, we can basically treat this as u, we treat this as v, and when you differentiate them accordingly using the product rule. So if I differentiate u, I get 3x squared, I keep my v, and if I differentiate v, I differentiate cotangent x, that's going to give me minus cosecant square. Okay, that's going to give me minus cosecant square. So differentiate cotangent will give me minus cosecant square x. So I can put it this way, multiplied by u, which is x cubed plus 1. This is dv dx, this is the u, this is the du dx, this is the v. Okay, simplifying my answer, I get 3x squared cotangent x minus x cubed plus 1 over, we can multiply with a cosecant square x. Okay, this is for part C. Okay, also I'm just using product rule and memorizing all the derivative of cotangent, cosecant, secant. Here, part D, we are asked to differentiate sine of 7x plus secant of 3 over 4x. Okay, so differentiating sine x, we basically at 7 cos 7x. And to differentiate secant, you must remember that we get secant tangent. So differentiating the outside function, we get secant tangent. Differentiating the inside function, basically just get 3 over 4. Okay, and that's for part D. Okay, so we have done with part D. Part E, we are asked to differentiate 1 minus cosecant over 1 plus cosecant. Okay, so this is 1 minus cosecant x over 1 plus cosecant x. So this is basically, I'm looking at it, it looks like quotient, so I can just use the quotient rule. Okay, I just use the quotient rule. Okay, and differentiating u over v, u die first. Just remember u over v. If I want to remember the quotient rule, I just remember u differentiate first. Okay, so what I can do, I can basically, there are a lot of ways to go about doing it. I'm sure your teacher may have covered with you in class. So I'm just going to show my way. If I differentiate u head on, differentiating cosecant will give me cosecant minus cosecant cotangent. So differentiating minus cosecant will give me a so-called cosecant cotangent. Okay, don't the minus du dx times v minus dv dx. So dv dx equals 1 plus cosecant. So dv dx will basically be minus cosecant cotangent x times u over v squared. Okay, simplify this, where basically you have cosecant x cotangent x plus cosecant square x cotangent x. Okay, plus over here you have cosecant x cotangent x minus cosecant square x cotangent x. Okay, cancel this, rewrite the denominator, and cosecant cotangent, add them together, you just have 2 cosecant cotangent over 1 plus cosecant x squared. Okay, and we are done with okay.